Welcome everyone. In my previous video we looked at setting up a enhanced safety throttle control for electric models. Basically the engine or the motor was locked out, you'd flick a switch, your motor would basically be switched off and you couldn't start the engine until the throttle stick was at a safe position, and that was at low stick, at bottom stick travel. You could then flick your motor off position to the motor run position and you could fire up the model. The only drawback with that setup, it's fine for an electric model, it just is not suitable for an internal combustion engine type model. And the main reason being is that we want a functional motor trim to be operative when starting the model. You don't have that issue with an electric motor. However, with internal combustion engine, you want to be able to have a trim. So basically you can actually set the correct idle position to allow for any atmospheric conditions or temperature changes on the day. So typically people that fly internal combustion models will set up a trim to a certain position, start the engine, and they might need a slightly faster idle or a slightly slower idle on the day, again depending on the atmospheric conditions. So for this particular model that I've set up here, I've just set up a single servo again. It's just 0 to plus and minus 100% travel. So with the trim fully reduced, I've got, you'll see here, this is just basically a servo channel monitor. I've got negative 100 at low stick, 0% at mid stick roughly, and then plus 100% travel at full stick. Fairly simple. I've also set up the trim, so in this particular case I'm using the inbuilt trim function. So if we go to our normal functions, I've got the engine control working off stick A. I'm using trim C for the actual trim function, which is this guy here. I use reverse trims for my models. So my aileron elevator trims are on the left hand side, yet I fly mode 2. So this is my aileron elevator stick. I just prefer to set up my trims that way. The trim C button or switch, you'll see on this graph here, we're just using the left mode. So the trim is only functional on the left hand side of the screen there. And if you can look carefully, you'll see the servo moving and the line moving on the graph there, indicating the travel for the servo. Nothing too out of the ordinary there for everyone. Of course, you can set up the number of steps and the range that the trim is functional over, etc, etc. Don't need to go into that setup for this video. So, single servo, nothing too special. Okay, now this is my configuration. You may not like it. I prefer this configuration for myself. You might be able to use some handy tips to set up your model, or you're more than welcome to use exactly the same setup as I've got. So for my internal combustion engines, what I normally do is I'll use a 3-position switch, and I'll just use this switch here because it's convenient for me as I'm on the right hand side of the transmitter. And what I normally do is I'll have an engine kill position, I'll have an engine start position, and then I'll have an engine run or a takeoff position for my aircraft. So engine kill overrides everything. It'll just kill the engine, similar to the electric model. Basically locks the throttle to 0, engine off, engine dead, totally safe. Okay, how do we do that? So, in my case, I use a switch in conjunction with a flight mode. So, what will happen is we'll use a switch to activate the servo cutoff. The servo cutoff will lock this servo to negative 100% travel. In other words, 0 motor throttle, or carburetor fully closed. However, it'll also activate a flight mode, and the reason I activate a flight mode is it allows me, or gives me further options within the programming. Because if I just use a servo cutoff, that's basically it. I can just lock the servo and that's it. However, if I also engage a flight mode in that engine kill position, I can also then adjust my flight surfaces on some of my other models, specifically for my helicopters. I can say set 0° pitch or whatever, all driven from the flight mode selection. Okay, it's very easy to do. Let's go into flight modes. At the moment, I don't have any flight modes enabled, or I should say there's the default ones enabled, the normal. And actually, I might just change the name of that to takeoff. Oops, wrong button. or wrong key I should say. Might make a bit more sense if I just use takeoff for this example. So you notice all the flight modes are set to takeoff because we haven't sort of set any, so it's just using the default setup. However, the one on the far left hand side, don't forget, has the highest priority. So for an engine kill scenario, I want that to have the highest priority. So once that's activated, that's it, nothing can override it. So let's use this switch to activate the, we'll call that engine kill. So let's select the switch and we'll use the default setting of on, so it's on when it's pushed away from the pilot. So let's change this name so it makes a bit more sense to us. I've got the voice active for my flight modes, as you probably heard. And let's call this one, say, engine kill. So let's go and type this in. Should get a smaller stylus, eh? Camera gets in the way, sort of blocks my vision of the screen sometimes. Okay, so at the moment I've just got the one flight mode activated by this switch in that position. So if I flick it to the middle position,
takeoff,
goes to the normal takeoff flight mode,
engine kill,
and then we've got the engine kill. So that's fine. So I've got engine kill, however our servo's still working, which is what we don't want. We want to be able to kill that. So what we're going to do to kill it, we're going to use the servo cutoff, which is probably the easiest way. So let's go into servo cutoff. Let's make one for the throttle. Now this should be fairly simple for most core and Atom users.
takeoff,
We'll use a switch
engine
again.
kill,
And same position on. And we'll set the position to the carburetor fully closed, which is negative 100% on this particular model. So now whenever we flick the switch,
takeoff,
if I'm in the takeoff position, I've got normal control. However, if I go to engine kill, we do two things. We enable the servo cutoff, plus we activate that flight mode called engine kill. And now you notice we've got no throttle control. So that's engine kill, totally safe, model's totally safe, that's fine. So that's fairly easy. I'm sure you're all following that so far. The next step's a little bit trickier. So in the next step, we're going to set the engine start position. So the switch will be in the middle position.
takeoff,
So I'm going to change the name of this flight mode to engine start in a second. However, in the engine start position, we want to be able to use the trim. So you remember with the servo cutoff, so if I select the servo cutoff, so I've got servo cutoff enabled now, notice the trim doesn't do anything. If I go back to the home screen, you notice the trim up there is moving up and down, yet we've got no throttle control. And we don't really want that for a internal combustion engine. We want to be able to muck around with the trim. So how do we get around that? Well, you'll see how we do that in a second. We're going to do two things. So when we have this in the engine start position, we're going to have a flight mode where basically the servo cutoff won't be doing anything. So the servo cutoff will be disabled. However, the way we're going to kill the servo is we're going to use the flight mode and we're going to select the curve, the throttle curve, to be a flat line at negative 100%. So basically when the stick moves, we're just going to be moving through that negative flat 100% curve. So basically all along the stick travel, the value will be negative 100%. And the reason we're doing that is so we can still use the trim, because the trim is still functional. Whereas if we use the servo cutoff, we can't use this trim. So let's select, just go into, say, flight mode. Let's temporarily select the next priority down with the switch.
engine kill, takeoff,
So let's use the middle position. So let's call this flight mode.
takeoff 2,
I'm not going to call it takeoff 2. I'm going to call it, say, engine start. Isn't it good that we've got a text-to-speech converter on these radios compared to having to download WAV files and stuff around with WAV files? It's a lot easier just to type something in and just select the voice. Okay, so now we've got this engine kill and engine start. Now, this switch here, this switch J for the middle position, we're only going to temporarily set this up because I'm going to change that to a virtual switch a little bit later. And the reason I'm going to change it to a virtual switch is I want to have this option here, engine start, only selected when this switch is in the center, which is fine as it is now. However, I also want to detect where the throttle stick is. I want it to be at low throttle to select this particular flight mode. We'll program that in a second. So let's kill the throttle. So at the moment I've got this selected, this flight mode selected. However, we still have full throttle, which is what we don't want. How do we get rid of it? It's actually quite simple. So if we go into our functions, into the curves for the function, not for the servo, but for the function, notice we have a straight line here. And if I switch flight modes, say to the takeoff position, have the same curve.
Engine start.
So let's go to the engine start. Now if you notice, the blue cursor will move over to the right. Hopefully that shows up okay on the video. And as I'm moving, that basically shows my throttle position or throttle stick position. And the graph shows the relative output for the servo. So if we actually reduce this graph down to minus 100%, as we move the blue cursor from left to right, its output's always going to be minus 100%. In other words, the servo will be locked to the carburetor fully closed position, basically. So, easiest way to do that is just to go into the Edit menu for the curve. All you need to do is select a basic 3-point curve, and actually I'll just go to the center dot, or center point I should say, and let's reduce that from 0 to negative 100, and you'll notice the servo's moving. And let's go to the top point now, and let's reduce that from plus 100% down to negative 100. And you'll notice the servo now is at the carburetor closed position. So as we move the throttle stick, we're just moving along a flat line curve that's fixed at minus 100%. Now you notice the servo's moving a little bit at the end there, and that's because of the trim. So if I reduce the trim back to 0, we've just got no control of the servo. However, we have a functional trim still. So if I move the trim up, so here we can start the engine and control the idle position with the trim. So if I just click on OK, and you'll notice that's the relative trim setting. Below half trim, I have no servo travel. It's just the way I've set it up. And then my trim or my idle trim is just operational over that top half of the range. Simple as that. So now we have a functional idle trim. However, the throttle stick does nothing. As a matter of fact, if we start the engine now, so say we go to about there, I hit the starter, I might turn my glow driver on, fire up the engine's working away, I might even advance the trim a bit more. If I bump the throttle stick, if I start to increase it, watch what happens to the servo. It'll actually reduce its travel. Notice it's reducing its travel very slightly. And if I keep going, it basically goes all... When I'm about half stick, this servo now is in the carby fully closed position. So if you bump the stick, the worst thing that's going to happen is your engine dies if you bump it far enough. Sometimes if you forget to flick this switch, as you go to advance the throttle, you hear your motor start to slow down a bit, and then that gives you a bit of a heads up saying, hey, you know, you've got this in the wrong position, you want to be in the engine run position or takeoff position. You can set up an audio warning as well on the stick if you're really pedantic. I haven't bothered to do that. So again, we have functional trim. Remember, in the servo cutoff position, so in the engine kill flight mode, the trim doesn't work. So the carby's now fully closed, we've got no trim, no control over the throttle, over the carburetor. It's just basically fully closed. Engine start. Engine start, we have trim control, but no throttle control. So basically the throttle's dead. So there's no way of having a hot start. So typically with a helicopter, it's pretty easy to have a hot start if you're not concentrating. You might have your stick up a bit high, you know, you bump the stick, you hit the starter on the engine, and you know, you burn out your clutch, and it sort of kills your day. So that's really handy for heli pilots. And same when you're starting a fixed wing model as well. It's less dangerous situation if you can't advance past your normal idle setting for your motor. You're not going to get a hot start on your little glow model, for instance, or your large glow model or petrol model. So again, it's just a good safety feature to have. Now, we're going to incorporate one little more step. So if we flick the switch to the takeoff position,
Take off.
you don't want your stick to be, say, at full throttle.
Engine
So this is similar to the electric model. At the moment, we haven't programmed it fully yet, but if I flick into takeoff, I'm in the engine start position, flick to takeoff,
Take off.
carby goes to full throttle, model goes berserk. We don't want that. We want to be able to basically go to takeoff position, and then basically the radio will force us to reduce the stick to the minimum position, back to idle, before we can actually take off. And how we're going to do that is we're going to use the virtual switch to do that. And this is where we're going to use the virtual switch to actually select the flight mode. So it's a bit of a trick where we're using the virtual switch to activate a flight mode, basically. Let's go into our virtual switches. Let's make a new virtual switch. So this is going to be programmed exactly the same way as the safety throttle on the electric motor video that I previously posted on YouTube. So let's call this one VTHR for virtual throttle. We're going to use the same logic here, so we're going to use this logic SR. We're going to check two things. We're going to check the position of this switch relative to the throttle stick. So let's program the switch first. So let's select let's select the switch. Now we have to set this correctly. Just be aware, I'll remind you again, I did this in the last video. My switches are set to hardware reverse entities, so they may be different on your radio. Just means this cursor will be swapped around 180 degrees as far as its functionality is concerned. Okay, so what we need to do in this switch setup here is basically the two positions where the throttle stick will be off, or has to be off. We want the cursor to fall into the red zone. So I've got fully forward and middle position. In the takeoff position, we're going to have the cursor fall in the green zone, and that's where the throttle will become active. However, we're also going to compare it to the throttle stick. So that's the switch done. Let's now program the throttle stick. Again, exactly the same as the electric motor video. We're going to have a red zone right down the bottom here at -95. Oh, that was a bit of a fluke. I got it without having to use the arrow buttons. And that's going to be set to 94. Okay. So now, when this is on, basically our start position will be locked to start. So you won't be able to move out of the start flight mode. So, engine kill. We flick to engine start, and we've got no throttle control, remember, on the servo, so it's not moving. We can adjust the trim, hit the engine with the starter if you've got a remote starter or just a normal Sullivan motor type starter or whatever. Fire up your engine, adjust the trim to suit. You might want a slightly faster or slightly slower trim. So we can see there, we're adjusting the trim, that's fine. If we bump the throttle accidentally, it goes back to 0, so that's a safety feature. However, another safety thing is if this throttle's bumped up a little bit, you don't realise it, and if we now switch to the takeoff position, or the normal engine run position, you'll notice this logic switch is still on, and it won't switch off. Just ignore the servo at the moment because we haven't programmed the flight mode yet. You notice this will only switch off once I reduce the stick all the way back to 0, or basically the bottom stick travel. And now it's gone off, and now we'll be able to control the throttle properly. So, one more step. Go back into our flight modes. And this engine start, we're going to remove the switch J from here and replace it with this virtual switch. So let's remove switch J and select virtual throttle. Okay, so now we're in the takeoff position. I'm at low stick, so when I flick this to start, it should go back to start. Engine start and engine kill. So engine kill.
Engine start.
Engine start, we've got trim control, no dramas there. And with the stick at low throttle, it'll go to takeoff.
Takeoff.
So takeoff, we've got normal throttle control. Remember, engine start,
Engine start.
we don't have throttle control, but we've got trim control. Now, we're in engine start, we've started the motor. I bumped the throttle actually a little bit to say just under half throttle. Remember, if you go past half throttle, it'll kill the engine. Let's say we're at, I don't know, 1/3 throttle. We don't want any surprises. So what happens when we flick to the takeoff position? Nothing. It still remains an engine start. However, if I reduce the stick all the way down to 0,
Takeoff.
it now switches to takeoff, and now we can take off on the runway or wherever and fly normally. Simple as that. Well, I know it's a bit more complicated this, but hopefully you sort of followed it through. I suggest maybe having a bit of play with the programming, follow my steps in the video. It should make a bit more sense if you play with it on your own core or Atom radio. Thanks for watching all.
Engine start.
If you have any questions, shoot me a message in the video. Thanks for watching.